Kia ora koutou, my name is Maggie and I'm a PhD candidate at Victoria University of Wellington School of Architecture. My research focuses on how cities and buildings can provide habitat for native species. The habitat loss and degradation that results from rapid and increasing urbanization is a primary threat to global biodiversity. Biodiversity loss negatively impacts ecosystems, thereby reducing ecosystem services and exacerbating climate change, all of which have negative implications for human well-being. While cities may be in short supply of available ground-level habitat, there is great potential for our buildings to supply vegetated habitats for native species, to supplement existing urban green space and create refuges for urban biodiversity. Regenerative architecture strategies such as green roofs and green walls can provide food and shelter for urban biodiversity, purify the air, moderate temperature, absorb noise, and improve stormwater management. For the first phase of my research, I investigated how to increase the quantity and connectivity of habitat in Wellington for its native birds using building roofs. The Central Business District neighborhood of Te Ato was selected as the focus for my spatial analyses because it currently has the lowest provision of urban green space in central Wellington. Previous research in Aotearoa, New Zealand has recommended a minimum target of 10% habitat coverage in urban areas to stop the decline of native biodiversity. I found that green space covers only 7% of Te Ato, and few of the green spaces have a plant community similar to the native habitats. Previous research has also recommended a habitat patch pattern for urban environments that would help improve the health and functionality of native ecosystems. I use this patch pattern to analyze the connectivity of existing green spaces in Te Ato and found areas that are isolated from other green spaces. There are 5 small habitat patches required in the northeast side of the neighborhood, and a larger habitat patch is needed near its center to achieve the recommended habitat connectivity targets. In total, roofs cover 37% of Te Ato. To achieve the 10% habitat coverage target, 9% of Te Ato's roof area needs to be converted to green roofs. One strategically located cluster of roofs and a series of smaller green roofs are required in the highlighted areas to improve habitat connectivity for native birds in Wellington. Though larger habitats can provide benefits to native birds such as reduced travel time to food resources, the green roofs outside of the key areas could be more flexibly distributed based on building height, typology, or retrofit needs. Using buildings to increase the quantity and connectivity of habitat in Wellington is possible, and there are cities around the world that are already doing it. For example, despite Singapore's rapid population growth, the city has managed to increase its urban greenery coverage to 50% as a result of initiatives that have pushed for the implementation of skyrise greenery. Projects like the Park Royal Hotel in Singapore demonstrate how integrating habitat in our buildings can benefit urban biodiversity and be aesthetically pleasing for people. While there are many benefits for people living in cities, there are also negative physical and mental health consequences, namely higher incidences of stress, obesity, and depression. However, there is a large body of literature providing evidence for the positive impacts of nature on stress reduction, social cohesion, and improved mood. Building cities that foster these positive interactions is important for the current and future well-being of urban residents. Urban environments cover 3% of the planet's surface, but are responsible for 38% of global carbon emissions. Providing space in our cities for vegetation to perform its climate regulation functions, such as evapotranspiration and carbon sequestration, can help mitigate climate change. The large-scale implementation of green roofs and green walls could help lower the carbon footprint of our cities, while also reducing the urban heat island effect and improve stormwater management. For the next phase of my research, I will be building a series of green walls on the Kelburn campus to quantify their thermal performance benefits and the resources they can provide native birds. Overall, my research aims to contribute new empirical evidence, strategies, and designs to advance regenerative architecture practices in urban environments so that we can create healthy, biodiverse, and resilient cities.